Dude, take a look at this picture of stars.
Okay.
Are there any differences between them that you can make out?
Well, they have different colors.
Right? Anything else?
Some are brighter than others.
Yes, color and brightness are really the only differences that we can distinguish between stars just by looking up at them. Because even though stars vary greatly in their actual size, from here on Earth, they all just look like points of light.
Right.
Now, importantly, how bright a star appears to us depends on two things: how far away it is, and how much light it's actually giving off, what we call its luminosity, which is something we can easily calculate once we know the star's distance.
Okay.
So here's what I'm getting at. What if, just for fun, we organize stars based on these two simple properties, luminosity and color? We observed tons of stars and put them on a graph, placing the bluest stars towards the left, the reddest stars towards the right, the most luminous stars up top, and the dimmest towards the bottom. And voila.
Voila.
What we just created here, my friend, happens to be the most important diagram in all of astronomy. The legendary HR diagram. At a glance, this thing tells you everything you need to know about any star in the universe.
In what way?
Well, what you might have noticed is that stars don't just have any random combination of luminosity and color, but rather, when organized based on those two properties, they fall into very distinct groups. The vast majority of them fall on this roughly diagonal line, telling us that, in general, the brighter a star is, the bluer it is, and the opposite. The dimmer the star, the more red. Now, as it turns out, a star's color is directly related to its surface temperature. And this might be counterintuitive, but the bluer a star is, the hotter it is, and the redder the cooler. So, in most cases, hotter equals brighter, and cooler equals dimmer. But interestingly, some cool stars are insanely bright, and some hot stars are really, really dim. So what's the deal?
Yeah, what is the deal?
Well, perhaps the most profound thing that this diagram reveals to us is stellar evolution. It tells us how stars grow up, get old, and die.
How?
Well, it goes like this. When a star is born, how massive it is will determine where it initially takes its place on this diagram. And as the star ages, its position will slowly change. The reason that most stars lie on this diagonal portion is because it is where every star begins and spends the majority of its life. These are stars which are still using their main fuel source to generate energy, fusing hydrogen into helium in their cores. Now, the high mass stars burn through this hydrogen fuel much faster, so they run hotter, thus appearing bluer and shining brighter, as opposed to low mass stars, which are much more fuel efficient, and thus cooler, redder, and more dim. Now, when stars eventually run out of their initial fuel source, various mechanisms within them cause them to expand. Low mass stars grow into giants, while higher mass stars swell into supergiants. And in that expansive process, stars cool off, at least at the surface, and therefore become more red. And once a star depletes all of its usable fuel, it reaches the end of its life. Giant stars die by shedding their outer layers and leaving behind their exposed cores. These are those really dim blue stars. They are stars which are already dead. Now, the supergiants have a much more cataclysmic death. They collapse and explode in a supernova, leaving behind what's known as a neutron star or a black hole, neither of which are luminous enough to even be on this diagram. How amazing is it that with an understanding of color and luminosity, two rather straightforward properties, we can understand the most fundamental objects in the cosmos, stars.